Alright, ladies and gentlemen, welcome back. This is going to be a quick video. There will not be a worksheet after this video, so it is very important that you demonstrate what you have learned on your graphic organizer and on your whiteboard practice. This will be quick and easy. Today we're going to talk about equivalent ratios. Okay? And equivalent ratios are just like equivalent fractions. It means that they show the same amount. Okay? And we're going to show that in just a second. Your objective for this video is, as a student, I will be able to find equivalent ratios. So, here we go. You're going to need graphic organizer. We're still on side 1. If you remember from the last video, I told you we were just doing the top part. Today, this is the only part that you are doing, this bottom part. You'll need to write down 3 examples, and I will show you where those are at, the definition, and of course you have 2 exit ticket problems. We're going to go ahead and get started. Okay? Equivalent ratios, what are they? Well, you needed the definition. Here it is. Equivalent ratios are ratios that name the same comparison. So, they're showing the same comparison. Remember, a ratio is a comparison of 2 quantities. Well, equivalent ratios show the same thing. You've even done a couple equivalent ratios because I had you simplify on your last video. Now, you can find an equivalent ratio by multiplying or dividing both terms of a ratio by the same number. I'll show you that in just a second. Okay? Here's a word problem that actually uses equivalent ratios. Okay? We will do this one at the end. Question says, at the swimming club there are 2 boys for every 3 girls. There are 15 girls altogether. How many boys are there? And how many girls would there be if there were 12 boys? So these are just a thinking question, and those are equivalent ratio questions. Let's get moving. Okay? So equivalent ratios. Simply put, you increase or decrease both sides equally. Okay? This is not your example. Just to let you know, this is not your example. If you see this one right here, we have 2 to 5, or 2/5. Either one, if you want to think about it as a fraction. Remember, we can write it in 3 ways. Okay, if you multiplied both of those terms by 2, you would get 4/10. Those are showing the same thing because they are equivalent, just like they are equivalent fractions. Okay, same thing if we had it 1 to 2. Okay, if we multiplied both of those by 4, you'd just get 4/12. And 7 to 2, if you multiplied both those by 3. Alright, we're going to continue. Yeah, they made an announcement trying to mess up my videos. Let's continue. Alright, equivalent ratios. This is examples number 1, 2, and 3. So I'm going to write these down here at the side. You just need to pay attention. This is example number 1. Okay, we have 2 over 3. That is our ratio, 2 to 3. And if I want to find the equivalent ratios, it said I can either multiply or divide both of them by the same number. So I can't really divide 2 and 3 because there's nothing I can divide them by. Kind of remember those are prime numbers. But I can multiply them by anything. So let's multiply them both by 2. So that would give me 2 times 2 is 4. 3 times 2 is 6. I can also multiply them by 3. 2 times 3 is 6, and 3 times 3 is 9. I can multiply them by 4. 2 times 4 is 8, and 3 times 4 is 12. And I can also do 2 more. Let's do times 10, which would give me 20 over 30. And let's multiply it by 25. And that would be 2 times 25 is 50, and 25 times 3 is 75. So those are our equivalent ratios for example number 1. We'll do example number 2 as well. Same thing, maybe I want to multiply it by 2. That gives me 10 over 8. If I multiply it by 3, that gives me 15 over 12. Times 5, that'd be 25 over 20. And maybe I want to do times 6. And that can be 30 over 24. And maybe if I want to do it times 30, that would be 150 over 120. Ladies and gentlemen, in this particular case, with what we're doing today, you get to choose what you want to multiply them by. But they have to be different for each one of these little boxes that you fill out. That's all I'm asking of you. Okay, this one I can actually divide or multiply. Okay, so this time I'm going to actually divide because I'm going to divide them both by 10. Why not? Dividing by 10, 8 divided by 10 is 8. 40 divided by 10 is 4. What if I wanted to divide them both by 20? Let's do 80 divided by 20 gives me 4. 40 divided by 20 gives me 2. What if I want to divide them by 40? Why not? Ooh, that would give me 2, and that'd give me 1. What if I wanted to multiply them by 2? I can do that too. That'd be 160 over 80. And finally, what if I want to multiply them by 10? Why not? That's easy. That'd be 800 over 400. Those are all you need. Okay? Those are your 3 examples. Ladies and gentlemen, good luck. So here's the deal. I want you to do the same thing. I want you to write 4 equivalent ratios for each of these numbers. We have 4/6, 3/8, and 9/3. Okay? All I want you to do is write them, pause the video, do them on a whiteboard, show them to Mr. Williams. Once he says it's okay, you're going to come back and you're going to do your exit ticket. This is it. This is video. That's it. Go ahead. Do it. And if you're back, here's the exit ticket. So here we go. Oh, wait. Can't do the exit ticket yet. Got to do this problem. All right. Real quick. It says there's 2 boys for every 3 girls, right? And it says there's 15 girls altogether. So how many boys are there? Well, that's really simple. We have 15 girls. So these are equivalent fractions. How does 3 become 15? Well, we multiply by 5. So 2 times 5, well, that's 10. So we have 10 boys. 10 boys. And it says, how many girls would there be if there was 12 boys? Well, remember, it's 2 boys to 3 girls. And this time it says, well, oh, hey, you got 12 boys. How many girls do we have? Well, we don't know. Well, how does 2 become 12? Times 6. 3 times 6, well, that's 18. So that would be the answer to this word problem that is using our wonderful equivalent ratios, which is awesome because in the next video, all it does is use equivalent ratios and you have to figure them out, and it's the coolest thing ever. I love it. It's the best part of the year. That being said, here's your exit ticket. Ladies and gentlemen, good luck. And on this note, I'm out.